Okay, so so we're getting into motion and how we describe motion. Hello, Arian. Okay, so there are two broad categories of quantities, okay? So we're going to have scalar quantities. So write this down in your notes, okay? So we have scalar quantities, and we're also going to have vector quantities. Maybe I'll do vectors over here. Okay, so when we are describing motion and communicating motion, we're going to use either scalar or vector quantities. And up there, so we were talking about scalar quantities first. So scalar quantities have only a size or amount. Okay, it does not tell us which direction it's moving. It just tells us the amount of it. Okay, so scalar quantities only tell us the amount. Tell us the amount or magnitude. Okay, so if I'm just saying that a scalar quantity only tells us the magnitude, this means it only tells us the amount. So for example, we could say a student lives 5 kilometers from the school, or we could say a vehicle travels at 110 kilometers per hour. Okay? It only tells us the magnitude, does not tell us the direction. Okay? So can anybody think of a scalar quantity that we use in our lives? Something that does not have a direction, just a size, just a magnitude. Okay, I will help us out. So an example of one would be mass. Okay, my mass is 60 kilograms. Okay, it's not 60 kilograms up, 60 kilograms down, 60 kilograms east, west. Okay, it's 60 kilograms. Okay, so mass would be an example of a scalar quantity. Can anybody think of another one? Time is another one. Okay, time is a scalar quantity. Mass, time. Distance is going to be another one. Speed. So in these cases, a student lives 5 kilometers from the school. This is a distance. A vehicle travels at 110 kilometers per hour. That is a speed. Alright, so these are scalar quantities. Okay, scalar quantities, think simple. Okay, S&S, simple, only the magnitude / the amount, does not tell us the direction. Okay, conversely, we have vector quantities. Okay, these are going to have a magnitude and a direction. Okay, so kind of building off of our last examples, we had a student living 5 kilometers from the school. That is a scalar quantity. In this case, because it's a vector quantity, a student lives 5 kilometers south of the school. Okay, this is also known as displacement. Okay, and we will talk about that in a bit. Just right at this moment, you need to know displacement and distance are not the same thing. Okay? They are not the same thing. They're related, but they are not the same thing. Okay? Distance does not equal displacement. Okay, and in our second example, a vehicle travels at 110 kilometers per hour north. Okay, we have our magnitude and our direction. Okay, so this is going to be velocity. Okay, so a couple examples of vector quantities are going to be displacement, velocity, force. Okay, so right now the acceleration due to gravity on Earth is pulling all of us towards the center of Earth, right? That's what's keeping our feet and our chairs on the ground. Okay, so the force is acting in a downward direction, so that is a vector quantity. Okay. How are the notes? Okay? Yeah. I feel like this was something that we needed to write down, so that's why we have a little bit different notes than last time. Okay, so scalar and vector quantities, not the same. Okay, scalar has only a magnitude and vector has a magnitude and a direction. Okay? Okay, so that's a big one. Make sure by the end of today you know the difference between a scalar and a vector quantity. Okay? Okay, so now we're going to talk about distance versus displacement. So distance is a scalar quantity. Okay, so it only describes the length between 2 points and location. Okay? So, for example, this distance, that is going to be the length traveled to get to a particular location. Okay, so for example, I drove like 101 kilometers this morning. Okay, but if I was able to fly in my helicopter that I don't have yet, it would probably be closer to like, I think it's around like 67 kilometers if I drove straight from Lethbridge to Vauxhall, like across all the farmers fields and stuff like that, right? But of course I have to take the roads because I only have a car, right? So, yeah. Okay, so distance is a scalar quantity. The symbol for distance is just going to be a d. Sometimes you'll see it as a delta d. And remember, anytime that we see a delta, what does that mean? Yeah, perfect. So it just means a change in something, okay? So delta d is going to be my change in distance, okay? Change in distance. Good. Okay, now we're talking about displacement. So displacement is a vector quantity. So it describes the length and direction between the two locations. Okay. Displacement also refers to how far the object has traveled from the starting point. Okay, so in this case here, we would say this is our origin. Okay, so how far are we from that origin? If this was my Vauxhall example, okay, if I drove 67 kilometers, 67 kilometers would be my displacement from the origin. Okay, displacement is how far something has traveled from the origin. That's really important. Okay, make sure you write that down. Put a star beside it. Okay, so right now I would be 67 kilometers away from home, right? Even though I traveled, what did I say, 101 kilometers? Even though I traveled 101 kilometers, my displacement is still going to be 67 kilometers, okay? So displacement does not equal distance, okay? Related, but different. Now, for displacement, it's close to the symbol for that, and I don't want you guys to get these confused, okay? So displacement is also going to be delta D, but because it is a vector quantity, it's going to have a little vector hat / vector arrow on the top of it, okay? So this is displacement, so delta D with a vector arrow / a vector hat on top. Okay, so that is displacement, not to be confused with our delta D distance, okay? This is a scalar quantity. It does not have a scalar hat, okay? Displacement is a vector, scalar quantity does not have a vector hat. I don't know if I said that right. But displacement is a vector quantity, so it will have the vector hat on top, okay? If you see this arrow, okay, do not be afraid of the arrow. It just means it's a vector quantity. So we're not dealing with distance, we're dealing with displacement. Okay? Are we all good with distance versus displacement? Mitch, can you tell me about displacement without looking at the board or your notes? Or go ahead if you need it.
I'm too tired.
Okay, so is it a vector or a scalar quantity, displacement?
Vector.
Yeah, it sure is. It's a vector quantity, okay? And Brennan, is distance a vector or a scalar quantity? Yeah, you bet, okay? So, distance is scalar, displacement is vector, okay? Don't mix up the two. They're related, but not the same thing, okay? Okay, so let's go over an example for distance and displacement. Okay, so a person is running around a 200-meter track and then returns to the finish line or the starting line. You know, it's the same thing, right? So if we're starting here, the person runs all the way around the track and returns to the origin. Okay, returns to the origin. So, first question is, how far has the runner traveled? What was the distance the runner traveled? Yeah, 200 meters, right? So distance, so delta D, no vector hat, is equal to 200 meters. Perfect, yeah, because that runner went around the track one time, it was 200 meters in length, and returned to the origin. So it's around 200 meters for sure. Okay, what is the displacement of the runner if it is back at the origin? 0. I agree, right? So 0, here is our origin. And remember that displacement is how far the object is from the origin, right? So if it starts, goes around the track, and it returns to the starting point, displacement is 0, okay? So delta D vector hat equals 0. 0 meters. Okay, can everybody see that? Okay, this is important. Make sure you know this. You might see it on an assessment. Okay, good. So, when you're calculating distance or displacement, some questions are going to ask you to find both, okay? And like what we just did in our last example, they're not always going to be the same thing, right? Sometimes they will be though. If a question asks you to find the distance traveled by an object, you'll simply add up how far that object has traveled. Okay? And we'll go over an example soon to kind of help me support that. Okay? When calculating displacement, you need to find how far the object is from the starting point / origin. Okay? Just kind of like our last example, the distance was 200 meters, but because the person was back at its origin, the displacement was 0. Okay? Okay, so we have an example, distance versus displacement. Okay? So, Mr. Jones drives 148 kilometers west to Castle Mountain to go snowboarding. After the day, I drive back 148 kilometers and I return home. So what is the distance that I have traveled? Well, we can draw a little picture to help us. So this can be my home. Live in a little green circle. Okay, and this can be our mountains over here. Beautiful. Okay, so I drive 148 kilometers west to go there. And then, after I'm done skiing, because I like sleeping in my own bed, I drive back 148 kilometers east. Okay? So the total distance that I've traveled, I went 148 kilometers west, and I came 148 kilometers east. So it'd be 148 kilometers plus 148 kilometers is equal to 296 kilometers. Should I have a direction for this? Why not, Abe? There's no point.
Why would you need it there?
Why would I need it? That's a good question, right? So yeah, there is not going to be any direction on distance, right? Because it is a scalar quantity, right? Scalar quantity only tells us the amount, right? So that's why there is no direction for this. So this is going to equal delta D. So my distance traveled is 296 kilometers, okay? And now what is my displacement? How far am I from the origin once I've returned home? 0, right? Right. And the way that you can show this one mathematically, you can do 148 kilometers west plus 148 kilometers east. For Science 10, we don't really need to set up our equations or our problems as like positive or negative. But in some cases you'll have to, in like physics 20 and stuff, so don't worry about this too much. You're just going to orient one direction as positive and one direction as negative, okay? So in this case, if I said west was negative, right, it would be negative 148 kilometers plus positive 148 kilometers, because that's going east is positive, is going to equal 0 kilometers. Is equal to delta D. And what am I going to put on this one because it's displacement? The vector cap, the vector hat, whatever you want to call it. Okay? Are we all good for distance and displacement? Yes? Yes? Okay. Good. Because now we are getting into speed versus velocity. Okay? So just like displacement and distance are related to one another, they're kind of the same thing. They are same but different, right? Same but different. So speed is a scalar quantity, so it only is going to tell us how fast the object is moving, right? Doesn't tell us the direction, right? It's just telling us the speed the object is moving. So this is a scalar quantity. So speed, like distance, again, is scalar. And what the variable for speed looks like is delta V, no vector hat, right? So because it's just a scalar quantity, so delta V is just speed. Okay, and our units are going to be important in physics, right? Make sure you always include units with your answer, right? Because obviously kilometers per hour is different than meters per second, right? Kilometers per hour is something you guys are probably most familiar with, right? Between driving and just the way that things are measured, that's usually the most common one. In physics, we like meters per second, okay? We like meters per second. So make sure if the question is asking you to report your answer in meters per second, you report your answer in meters per second, right? Okay, I'm going to show you guys a little trick to convert that pretty easily. Okay, so speed is scalar. You can kind of remember it from the S's, right? Speed, scalar. Velocity is going to be a vector quantity. Okay, so now velocity is a vector quantity, so it will tell us the distance and direction an object is traveling. Okay, so the symbol for velocity is delta V, but because it's a vector, what am I going to put on top of it, Ryan?
Vector cap.
Yeah, perfect. Perfect. Okay, so velocity is delta V with a vector cap, and speed is just delta V, no vector cap, right? It's scalar. So when you think vector, you need to think magnitude and direction. And when it's scalar, just think of magnitude. Okay? Again, velocity, vector, V, speed, scalar. I think those two are kind of easy to remember. Any questions so far? So Harrian, what is the difference between a vector and a scalar quantity? Okay, so vector quantities have magnitude and a direction, so it has two things. Okay, so make sure you write those down. Okay, and scalar quantities are only going to have a magnitude of the motion. Okay, here are our formulas for average speed and average velocity. Okay, so velocity is equal to displacement over time. Okay, remember, time is not a vector quantity, so it does not have the vector cap. Okay, so velocity is related to displacement, and speed is related to distance over time. Okay, so speed is equal to distance over time. And we have our velocity. So delta V is equal to delta D vector hat, so displacement over time. Okay, this is a big takeaway for today. So make sure you're able to tell me the difference between scalar and vector quantities. Okay? And yeah, these are just measurements. So to find the velocity, you just find how far an object has been displaced over a particular time period. And same for speed, but it would be distance instead. Okay? And you will be given these formulas on a quiz or something like that, okay? So don't worry too much about memorizing them. But something you need to just remember is that a delta, so is a change in something, and it's always going to be d2 minus d1 or t2 minus v1 or v2 minus v1, right? The second minus the first, okay? All right, so let's get into some calculations. Okay, so a car travels a distance of 500 meters in a time interval of 35 seconds. So what was the speed of the car, right? Because we have distance and we have speed. If it was displacement, what would we be calculating? Yeah, if it was displacement, we'd be calculating the velocity, right? But it is distance, so we're going to be calculating speed. Okay? So the formula you guys are going to see, and again, you guys will get on a formula sheet. So change in V. So remember, there's no vector hat. So this is speed. Okay? It's the exact same formula, if you guys haven't noticed yet, except for it has like vector hats and stuff. Okay, I'm honestly not too concerned if you guys just go in and you write V is equal to delta D over delta T. Okay, if you want to be like perfect, and you can totally include the vector hats or caps, not necessary. Okay, not necessary. But you still need to know the difference between vector and scalar. Okay, so anytime that you guys have a problem, a physics problem where you're given multiple variables and stuff, it's going to be easiest for us to first write down what we know in the question, okay? So a car travels a distance of 550 meters, so that is going to be my D. So distance is 550 meters, and let's just keep reading the question. And I could be careful, so delta D, right, change in distance. And in a time interval of 35 seconds. So that is our delta T. Okay, now to find the speed, we just have to enter these two variables into our formula. So delta V is equal to 550 meters divided by 35 seconds. Okay, now this is when our significant digits come into play. So Tanner, how many sig digs are in 550 meters?
3.
3, perfect. And in 35 seconds?
2.
2. So how many digits will our final answer have?
33.
No, 2. 2. Yeah, it's always the least amount of sig digs, okay? Yeah, so it's always the least amount of sig digs, so we will put our answer into 2 sig digs. Okay, so 550 divided by 35 gives us 15.71 for ... And what are units going to be on this? Meters per second, great. Because all we're doing here, we're dividing a meter by a second. So our answer will be meters per second. Okay, but we want our final answer to have only 2 sig digs, right? So when we are going, so here are 2 sig digs that we want, okay? So now we need to look to the right of it. And if it's 4 or less, let it rest. 5 or more, raise the score, right? This is a 7, so we will round that up to 16. So delta V is equal to 16 meters per second. Should I have a direction on this?
No.
Why not?
It's scalar.
It's scalar. Okay? Scalar has no direction. Okay? So the speed of the car was 16 meters per second. Okay? The speed of the car is 16 meters per second. And then once you're done at your final calculation, put a box around it to make my life easier. Okay? So far so good? Okay. So sometimes you're going to be given units you just need to be aware of your units, okay? So a car travels a distance of 1.3 kilometers, so our distance is 1.3 kilometers, and a time interval of 5.3 minutes. What was the speed of the car? And we want it in meters per second. Okay, so we need to change our units here. Okay? Does anybody know how many meters are in 1 kilometer? Yeah, 1,000, right? So to change our kilometers to meters, we're just going to multiply it by 1,000 meters in 1 kilometer. Okay, our kilometer units cancel. And then we will have 1,300 meters. And if we want to get minutes to seconds, what is my conversion factor there? How many seconds in a minute, Harriet? 60, right? Yeah, perfect. So we're going to multiply that by 60 seconds per 1 minute. Minutes will cancel. And then we get where is it? 5.3 minutes is 318 seconds. Okay, so now just to find the speed, we're just going to divide. So speed is equal to distance over time, which is equal to 1,300 meters divided by 318 seconds. And our speed equals 4.1 meters per second. And that's already rounded. Yeah, because you guys get is equal to 4.088, right? We have 2 sig digs and 2 sig digs. So our answer will also have 2 sig digs, right? So 4.08. We're going to look to the right of our second digit. It's more than a 5, so we round up. 4.1 meters per second. Okay, how are we feeling? Good? Cool. Okay. Sometimes you guys are also going to need to manipulate our formulas so we can solve for what is being asked, right? So in this case, we know our velocity. So velocity is equal to 33.3 meters per second north. Okay, if you ever see the square brackets and the letter inside of it, that's just indicating the direction, right? Because it's a vector quantity, velocity is. Okay, if the car travels for 60 seconds, so t is equal to 60 seconds, what will be the displacement of the car? Well, we know that velocity is equal to displacement over time. So if we want to isolate for displacement, what is the opposite of dividing by time? Multiplying by time, good. And I'm going to do that to one side?
Both sides.
Both sides, good. What you do to one side, you have to do to the other. Okay, delta t divided by delta t is equal to 1, so that will just cancel. And now we have displacement is equal to velocity multiplied by our change in time. And which we have, so our velocity is 33.3 meters per second multiplied by 60 seconds. So you guys should have your calculators out and doing this on your own to make sure you get the right answers. So if you multiply that, we get 1,998 meters. Am I done here? What do I need to include for my displacement?
Direction.
Direction. Good. And we're driving north, so my displacement is north. Joanna, do you have a problem with my answer right now? No? Does anybody?
Yeah.
It's not the same.
What is it? Let me know.
Oh wait. You need the cap.
The what? Oh, okay, sure. Yeah, so I need the cap. I'm not too picky about that, so that is not what I was really concerned about. But yes, you're right, Joanna. It's incorrect without the cap. I won't dock you guys marks for not having the cap. Maria, what do you have? What's your issue with this? Not in sig digs. Very, very true. Okay, we have 2 sig digs and 3 sig digs. So what's my answer going to be in Tanner? 2 sig digs. Good. Okay, so there's a couple ways that you could write this. So we are going to have to either change this into our scientific notation, or we could rewrite this as 2 kilometers. Let's do our notation first. So our decimal point is here, so we need to move it 1, 2, 3 spots. So we'll have delta D is equal to 1.99, which is going to round up to 2.0 times 10 to the 3 meters north, or 2.0 kilometers would be okay. And just like how you guys went from kilometers to meters by multiplying by 1,000, or other way around. No, yeah. Sorry. To go from meters, or to kilometers to meters, you multiply by 1,000. Going from meters to kilometers, you would divide by 1,000. Okay, that's just the opposite there. Okay? Cool. One more example for you guys, and then you guys will have some time to practice. Okay? So let's try this one on your own, please. Okay, so like you're going to do anytime that you're faced with a problem, just write down what you know. Write down your variables, okay? So it drives 148 kilometers west, and we're talking about speed here. So on the way there, so my distance is 148 kilometers. And my time is 1.5 hours, okay? So to find speed, so speed is equal to distance over time. Now I know you guys converted yours from kilometers to meters and from hours to seconds. Okay, I'm going to show you guys a trick that you guys are going to be able to use. Okay, so if you're in kilometers per hour, if that's your unit, there's a known conversion factor that's going to make our lives easier. So I'll show you guys after. So I'm going to do this in kilometers an hour. So 148 kilometers divided by 1.5 hours is going to give me an average speed of 98.67 kilometers per hour. Okay, and I know we are reporting our answer in meters per second, so write this down somewhere. Okay, I'll write it over here. So kilometers per hour to meters per second, simply divide by 3.6. Simply divide by 3.6. I can show you guys the proof for that if you want. Okay, so if I divide my 98.67 by 3.6, I get 27.4 meters per second. But I only want it in 2. So 27 meters per second is my speed on the way to Castle. Okay, you guys should have gotten 27 meters per second still, right? Okay, so yeah, so this is a nice little trick. You guys can use it. Okay, so make sure you write that down somewhere. And then of course, if you want to go backwards from meters per second to kilometers per hour, you just multiply by 3.6 as well. Do you like that roll? Do you like that trick? Helpful? Yeah. Saves us some time. Okay, so my velocity. So how is my velocity different than my speed? Right. It tells us the magnitude and direction because velocity is a vector quantity. You bet. So my velocity, my displacement is still 148 kilometers west, and my time is still 1.5 hours, right? So my velocity is going to be the same value, but just my direction will be included as well. Okay, so speed, scalar, velocity, vector, speed, magnitude only, velocity, magnitude, and direction. Okay? Questions? Okay. So, after the day, I am tired and it takes me a little bit longer to drive back. So so for speed, my distance is still 148 kilometers. My time now is 1.75 hours. So speed is d over t, which is 148 kilometers divided by 1.75 hour. And I know those are in different units than meters per second, but we know our conversion factor now. to easily go from one to the other. So 148 divided by 1.75. It's 85 or 84.57 kilometers per hour. Okay, and then to go from kilometers per hour to meters per second, I'm going to divide that by 3.6. And we want 2 sig digs still. So we have 23 meters per second. Do I want a direction on that, Abe?
No.
No, because it's scalar, right? And it is just speed. So Joanna, what do I have to change to make sure my part D answer is correct?
The direction.
Perfect, the direction as well, right? Because the displacement and the time is still the same, so we're just going to include the direction, so 23 meters per second. And on the way home, I am going east. Okay? Any questions so far? Feeling pretty good about physics so far? Yeah, a couple formulas? Yes?
Wouldn't C and E have to be 23.5?
For sig digs?
Yeah,
Um,
because it's 148, 1.75.
yeah, okay, so you're looking at just this portion of it.
Or is it still like the whole question?
It's still the whole question, yeah. So if I were to have like chopped it up, I guess, and made it 2 different questions, it would be whatever is there. But yeah, so in the whole question there is 2 is the least.
Okay.
So yeah, really good observation there, for sure. Good. Okay, so average speed and average velocity. Okay, so average speed is equal to total distance over total time. And I don't think this one actually made it into your notes, did it? No? That's okay. So just on the side, you can write this somewhere. Okay, sorry about that. I guess I added this one after. So yeah, average speed is total distance over total time. So my distance, 148 kilometers on the way there, and 148 kilometers on the way back. So total distance is 296 kilometers divided by my total time, which is 1.5 hours there and 1.75 back. So my total time is 3.25 hours. So 296 divided by 3.25 gives my average speed to be 91 kilometers per hour divided by 3.6 gives me 25 meters per second. V average okay. How is velocity different than speed? Brody, how is speed different than velocity?
Because speed is how fast you're going and distance is how far.
Okay, yep. I think I asked the question poorly, sorry. How is velocity different than speed? Yeah. So for velocity, we're going to have our displacement, right? And for speed, we have distance, right? So if I drove to Castle and I drove home back to the origin, what is my displacement for the day? 0. So what is my average velocity going to be for the trip? 0 as well. So average velocity is equal to displacement over total time, which is 0 divided by 3.25 hour, which is equal to 0. Okay? All right? Okay. Okay. And this is the last one. So, if I am meeting my friend who needs to only drive 100 kilometers, so D is 100 kilometers, what average speed should they drive if it takes 1.5 hours to get there? So we'll just do V, so speed is equal to distance over time, which is 100 kilometers divided by 1.5 hour, which is equal to, I did mine meters per second, but 100 divided by 1.5 gives us 66.67 kilometers per hour. And in meters per second, that will be, so if we divide that by 3.6, velocity is 19 meters per second. Or speed, sorry. Okay? All right. That's enough from me.